So, should have been easy graph. We have the square root of x. Y equals 2 is up here. Right? And x equals 0 is the axis. And we're revolving about this line. So when I revolve it, and yeah, these do meet here down eventually. Right? I'm revolving this way. Not around the x-axis, not around the y. Revolving about the line y equals 2. Okay, so our picture is not bad. Do I have any holes? No. It's a nice, neat, solid. So when I revolve this, oops, let me make that a curve.
Kind of like a sorry piece. Well, yeah, it kind of does.
It's going to look like those old record players.
Oh, okay. Yeah.
Okay. So, but here's the thing. We really don't have too much different other than our radius is going to change. But I revolved this way, horizontally, right?
Yeah.
That's similar to revolving about the x-axis. Okay? So if you revolve horizontally, everything better be in terms of x. Okay? It's the same motion, it's just shifted up or down. So when you revolve horizontally, it better be in terms of x. So then likewise, if you revolve vertically, in terms of y. That's a very big deal. Okay, so when I do this, there is no outside, inside. I just need the area function. R squared. But here's my problem with the r. When I draw my radius, I could draw it here, or I could draw it there. Usually there's one that's most helpful to us. Okay? Not always. Usually the one that's closest to the bottom, to the x-axis, is helpful. Because here's what I have to think about. The function's distance is this, correct? Mm-hmm. Right? Yeah. So my radius is not the function. It's 2 take away the function. You see how that's going to give me the radius?
Yes.
So it's 2 minus my function. That's the big thing. If you're revolving by line, you're going to use subtraction. Okay? But it matters sometimes if you get square root of x minus 2, it's not going to work out. Sometimes it will depend on the function, but... Okay, so here I have, I'm going to pull out the pi. I'll get my bounds in a second. I have that 2 minus square root of x squared. Yeah? Now to find the bounds, I need to find where they meet. We obviously know this one's 0. The other one, I have square root of x equals y. And I also know y is 2, so plug it in. X is going to be 4. Let's FOIL that out. I have 2 minus square root of x. 2 minus square root of x. So I have 4 minus 4 square root of x plus x. Go ahead and write that integral down now. So when I take my antiderivative, what is my antiderivative? 4x. Now that one over here is negative 4x to the 1/2. So when I add 1 to the power, I'm going to get x to the 3/2. Better take negative 4 divided by 3/2. Negative 8/3. Plus 1/2 x squared. From 0 to 4. So when I plug in 4, I get 16. Now over here, what will I get there? 64 thirds. Because remember, 4 to the 3/2 is just 8? Yes? Then plus, what will I get there? Careful. Careful. 8. Minus 0. Right? When I plug it all in 0. But don't assume. Make sure I do plug it in and actually get 0. Because sometimes I get a lot of people, especially with the e to the x's kind of thing. Assume, oh, when I plug in, I get 0. No, you don't. Not always. Okay, we know that right here. 24 minus 64 thirds. Let's go ahead and find a common denominator. When I multiply 24 times 3, get 72 minus my 64, 8/3. But I better stick my pi back in. thinking the hardest part of these problems, bless you, should be the setup. The picture and the setup should be what you take the most time on. Yeah?
Yeah.
Questions?